Okay, section 23, we're going to look at the graphs of trigonometric functions. As a starting point, it's a good idea to have an idea of what the sine, cos and tan curves look like. So y equals sine x goes up to 1 and down to -1. It climbs from the x-axis at 0, reaches a peak at 90 degrees, goes back down to the x-axis at 180, it then hits a trough at 270, and then back to the x-axis at 360. So that's y equals sine x. Y equals cos x goes up to 1 down to -1. It falls at 0 and down to the x-axis at 90. It then goes down to 180, back up to the x-axis at 270, and climbs back to 1 at 360. And that's y equals cos x. A couple of similar things about sine x and cos x is they go up to 1 down to -1, and they start to repeat themselves after 360 degrees. So if I was to keep drawing this curve at 360, it would start to repeat itself, as would the cosine curve start to repeat itself as well. Then we've got y equals tan x, and it looks a bit like that. So it climbs from 0 and then starts to repeat itself after 180 degrees, and it's got that shape, and that's called y equals tan x. Okay, so we've got some sine curves here, and we're going to identify A and B. So it's y equals a sine bx. A is the amplitude, and B is the number of curves in 360 degrees with the sine graph. So A is the amplitude, which is half of the total vertical height. So that's one way of thinking about it and getting an accurate value for A, is that it's half of the total vertical height of the curve. B is the number of curves in 360 degrees. So if I then look at these 4 curves here, well, the first curve goes up to 3 and down to -3, so that's a total height of 6, half that, and that gives me the amplitude, which is 3. I can see that there's one complete cycle after 360 degrees, so it's going to repeat itself after 360 degrees, therefore B is equal to 1. So the next one we've got this time a cosine curve, so it's going to be y equals a cos bx. So again, for sine curves and cosine curves, we can think about it the same way. A is the amplitude, half of the total vertical height, and B is the number of curves in 360 degrees. Well, this curve goes up to 2 and down to -2. That's a total height of 4, half that, and A is equal to 2. We can see that there's one complete curve after 360 degrees, so one complete cycle, and B is equal to 1. The next one, we've got a cosine curve again. So a cos bx. A is the amplitude, which is half the total vertical height, so the curve goes up to 4 and down to -4. That's 8, half that to get the amplitude, and A is equal to 4. This time there are 2 complete curves in 360, so B is equal to 2. Next one, we've got a sine curve again. So a sine bx. A is the amplitude, which is half the total vertical height, so the curve goes up to 3 and down to -3, that's 6, half that, and A is equal to 3. We can see that there is 2 complete curves in 360, so B is equal to 2. Okay, so we've got some more sine and cosine curves. So the first one, it goes up to 7 and down to -7. That's a total height of 14, half that, and I get 7, A is equal to 7. There's 1, 2, 3, 4 complete curves in 360, B is equal to 4. Next one goes up to 5 and down to -5. That's a total height of 10. Half that and I get the amplitude, which is 5. B, number of curves in 360, so it's 1, 2, 3 and 4. B is equal to 4. Next one goes up to 2 down to -2. That's a total height of 4. Half that and I get 2, so the amplitude is 2. There's 1, 2 complete curves crucially in 180. So it's how many curves are in 360. So again there's 1, 2 curves in 180. That's 4 curves in 360. B is equal to 4. Next one, up to 4 down to -4. That's a height of 8. Half that for the amplitude, and the amplitude is 4. There's 1, 2, 3 complete curves in 180. So that's 6 complete curves in 360. Okay, so again, it's a sine bx or a cos bx, and we're identifying in B. So again, A is the amplitude, half the total vertical height, so up to 6 down to -6. That's 12, half that, and A is equal to 6. There's 1 complete curve in 72 degrees. That means that there would be 5 complete curves in 360. Next one, up to 3.5, down to 3.5. That's 7, half that, and the amplitude is 3.5, 3.5. There is 1 complete curve in 120 degrees. So it's 3 complete curves in 360. Next one up to 2.5 and down to 2.5. That's a total height of 5. Half that to get 2.5. The amplitude is 2.5. There's 1 complete curve, 2, 3 complete curves in 180. So that's 6 complete curves in 360. Next one goes up to 3 down to -3. That's a total height of 6. Half that to get the amplitude, and the amplitude is 3. There is 1 complete curve in 720. That means that there's only half a curve in 360, and that's what we're interested in. So B is equal to 1/2. Okay, we're now going to look at tan curves. Now with tan curves, the amplitude cannot be measured. So what will be asked here for tan curves is the value for B. Now for tan, the tan curve, tan x, repeats itself after 180 degrees. So with sine and cos, the value of B is the number of curves in 360. But there's a crucial difference with tan. With tan curves, it's how many complete curves are in 180, and a complete curve is when it starts to repeat itself. So B is the number of complete curves, the number of complete cycles in 180. Now we can see that this curve up here starts to repeat itself after 90, so it repeats itself once and then twice. So B is equal to 2. For this one, it starts to repeat itself after 60, so it's once and then 120 twice, 180 third time. B is equal to 3. For this one, it's once after 30, so we can predict then that that would be 6 times, 6 complete cycles in 180. B is equal to 6.